Alright, this is part 1 of a lesson on polynomials. Obviously this was a test for my students, and students of mine, if you're watching this, probably you messed up on this test and now you're interested in doing recovery, and you're specifically watching videos for problems that you got wrong. Please do not have a pencil in your hand while you're watching these videos. Don't copy off of me. You're not learning that way. You think you are, but you're not. So watch the videos, learn how to do the problems, but then go back and do the problems by yourself. That's the only way that you can be sure that you actually know how to do it. Alright, for problem number 1, we're supposed to use this function to answer the questions below, showing all work. Part A, list the possible rational zeros of the function. So this is alluding to the rational zero theorem, which says that the rational zeros, the possible rational zeros, are going to have only certain numerators and certain denominators. The numerators, let's see, numerators. The numerators are going to come from the constant, and I'll explain what I mean by that in a second. The denominators are going to alright, so
there's a huge spider. Save me. Right there.
Oh god, it is huge.
wow. I wish you guys could see this. It looks like a movie tarantula or something. Alright, so this the denominators come from the leading coefficient. I'm not happy about this particular problem since both numbers are the same. You know,
Now I'm getting up again.
it's kind of a lame problem. But anyway, the numerators have to be factors of the constant term. So that's going to be plus or minus. Well, I'll do the plus or minus part later. The factors of 2 are 1 and 2. Alright, so that'll be the same thing for the denominator. So the possible zeros, for the possible zeros, we just mix and match these numerators with these denominators. In fact, let me color coordinate it a little bit. Okay, 1 and 2. So I'm going to put these numerators over each of these denominators. So start with the green denominator. So I've got 1 and 2. So I'm doing 1 over 1 and 2 over 1. And now I'm going to put the same numerators over this denominator. So I've got 1 and 2 again, but this time I'm going to put them over this denominator. So 1 over 2 and 2 over 2. Okay, but I need to reduce these. So 1 over 1 is just 1. So plus or minus 1. 2 over 1 is 2. So plus or minus 2. 1 over 2, of course, is 1/2. So plus or minus 1/2. But then 2 over 2 is 1. And we already have 1, so I'm not going to add anything on. So these are the possible rational zeros. Okay, now we're supposed to write the function in factored form, completely factored. But to do that, having the possible zeros are not good enough. We need to find some actual zeros. So what I would do if I were you, let's put this function into our calculator. I'm going to try the TI-30XS multi-view. Yeah, so I hit the table button, clear that function out of there. So we've got 2x to the third power plus x squared. Alright, so 2x to the third power plus x squared. Whoops, messed up. Let me do that again. 2x to the third power plus x squared minus 5x plus 2. So minus 5x plus 2. and hit enter. I like to start at -10 actually, because it rarely goes past -10. And what I'm doing, I'm going to scroll down looking for 0 on the y side. And so there I have 1. So that means -2 is a 0 of this function. Okay, so since -2 is a 0 of the function, I'm going to use synthetic division to factor it down. So let's use synthetic division. So I go -2, and let's see, my coefficients are 2 and 1, -5 and 2. Okay. Okay, so we bring down the 2, we multiply, and that's -4. Add, we get -3. Multiply, you get 6. Add, you get 1. Multiply, you get -2, and add, and of course you get 0, as we planned. Alright, so that gives us the trinomial 2x squared minus 3x plus 1. And from the -2, that gives us a factor of x plus 2. So this is what we have so far. But to factor completely, we need to see if perhaps we can factor this pink trinomial. So let's give it a shot. Okay, so looking at the 2x squared, that can only factor as 2x times x. Looking at the 1, that can only factor as 1 times 1. And of course we remember, everybody remembers, that the inner plus the outer has to give you the middle. So inner I have 1x, outer I have 2x. That has to equal the middle of -3x. Is there a way I can pick the signs to get -3x? Sure, if both of these were negative. So that would make this negative and this negative. Now, will that give me a +1? Sure, a -1 times -1 is +1. So we have factored it correctly. Don't forget to bring down your x plus 2. So now this is completely factored, and that's what we will write on the answer line. This right here. Actually, this is not the answer to this question, because for part C we're supposed to find all the zeros. For part B we're supposed to write in factored form. So to me these questions are sort of backwards, because we really need to do well, maybe they're not backwards. Anyway, strike that last thought. Bottom line is we have the factored form, so this is the answer to part B. So I'm going to put that up there. For part C, we need to set these factors equal to 0 and solve. So that's what we'll do now. Okay, so if I do x plus 2 equals 0, subtracting 2 from both sides, that gives me x equals -2. So that's one of my zeros. If I set 2x minus 1 equal to 0, okay, adding 1 to both sides gives me 2x equals 1, and then dividing both sides by 2 gives me x equals 1/2. Okay, so that's another 0. And of course, if I set x minus 1 equal to 0, adding 1 to both sides gives me x equals 1. So my zeros are -2, 1/2, and 1. Okay, and don't forget the fundamental theorem of algebra. Because the degree was 3, we knew there would be 3 zeros if you count repeated zeros and imaginary zeros separately. Alright, so we found all 3, so we're good. Okay, let's keep going. Problem number 2. Use the function and the graph to answer the questions below. So we're supposed to write this in factor form and find all zeros. Okay, so let's start with the zeros that we can see. Now notice the degree is 4, so I'm expecting to find 4 zeros. Now so far I see 2 zeros. Okay, it looks like -1 is probably a 0, and it looks like 2 is a 0. So we have -1 and we have 2. So let's do some synthetic division and to help us factor and find the other 2 zeros that we don't see here. They must be imaginary since you know, clearly we only have 2 x-intercepts right here, so the other 2 must be imaginary. So I'm going to start with -1 and do my synthetic from there. Okay, so -1. Looking at my coefficients are 1, -5, 7, 3, and -10. Okay, so now I'm going to go ahead and divide. So I bring this down, multiply, I get -1. Add, -6. Multiply, I get +6. Add, I get 13. Multiply, I get -13. Add, I get -10. Multiply, I get +10. Add, I get 0. Okay, so now I've got this. Not much I can do with this. If I put the variables back in, grouping would not work, but no worries, we have another 0. So I'm going to go ahead and use the 0 of 2 now. So I'm just going to put that down and continue the process. Okay, I think I'll use purple now. Okay, so multiply, I get 2. Add, I get -4. Multiply, I get -8. Add, I get 5. Multiply, I get 10. Add, I get 0. So now I have this. I'm going to go ahead and put my variables back in, and I see I'll have this trinomial x squared minus 4x plus 5. Okay, now let me go ahead and bring down the factors that I get from these zeros that I was given on the graph. So this 0 corresponds to a factor of x minus 2. This 0 corresponds to a factor of x plus 1. So far I have factored down to this. So the only question is, can I factor the purple trinomial any further? And you just got to try it out and see. Alright, if this factors, x squared will factor as x times x. 5 is prime, so it can only factor as 5 times 1. Alright, so the key is we know inner plus outer has to equal the middle. Inner, I have 5x. Alright, outer, I have 1x. Is there any way I can get -4 out of this? Yes, if I have a -4 and a +1, if I have a -5 and a +1, that'll make -4. Unfortunately, that means this would be a negative and this would be a positive. Am I going to get a +5 out of that? No, -5 times +1 would be -5. So that means that this is unfactorable, because this was the only way we could possibly do it, and it's not working. Okay, so this is unfactorable, so that means that in terms of factoring, this is now completely factored. Alright, so for part A, where it says write g of x in factored form, kabam, this is it. Alright, you just write down what you got so far. Okay, so now we need to find all zeros, and remember we were expecting 4. Let's start with the 2 that we got right off the graph. The first 0 was -1. We had -1 and +2 right off the graph. So let's go ahead and list that off. -1, and then we had +2. Okay, and they each corresponded to these factors. Now the remaining 2 zeros are going to come from this purple trinomial. It's unfactorable, so let's go ahead and use the quadratic formula. Okay, so the quadratic formula, opposite of b plus or minus square root. Actually, let's all remember the quadratic formula. Opposite of b plus or minus square root b squared minus 4ac all over 2a. This red part here is called the discriminant, and we always find that first. So let's do that. Let's do our b squared minus 4ac. Okay, so b squared minus 4ac. So remember, we're looking at this trinomial right here. So it's helpful to keep in mind that a, b, and c. Okay, a is 1, b is -4, and c is 5. Boom, boom, boom. Okay, so b squared minus 4ac is going to become -4 squared minus 4 times 1 times 5. Did we really need the 1? No, we did not. I'm just showing it so no one gets confused. So you should be able to evaluate this mentally, you know, because this is just 16, positive 16, and 4 times 5 is 20. So it's just 16 minus 20, so that's going to be -4. Okay, so we know this is going to give us imaginary solutions because we're about to have a negative number underneath the radical. So let's go on with the rest of the quadratic formula. Okay, so it'll be opposite of b plus or minus square root and then the discriminant. Okay, so let's see. Okay, so opposite of b. b is -4, so the opposite of b will be +4. And then plus or minus square root. Okay, then the discriminant goes under the square root. So there's our -4, goes right there. Over 2a. A is 1, so 2a will just be 2. So all we need to do is simplify this down. So we have 4 plus or minus. Now the square root of -4 is 2i. Everyone knows the square root of 4 is 2. But did you know that if you have a negative under the radical, that gives you I, thus 2i. And then that's all divided by 2. Now, do you notice that all three of these things are divisible by 2? Okay, so I'm going to draw a heart around those, okay, to remind us that when we have three things together, like a family of things that are all divisible by the same number, we have to do that. So we're going to divide all these by 2. Notice that if it were just the blue numbers, we couldn't do it. It has to be all three or nothing. Okay, so if we do that, we're going to get, so we'll have 2 plus or minus 1i over 1. Alright, but these ones, we're not going to really write these ones. You understand what I'm saying? Those ones are superfluous. So we're going to put x equals 2 plus or minus I. So these are our final two zeros. So we've got 2 plus I and 2 minus I. So these are the 4 zeros that we were looking for. And you can feel free to leave it as 2 plus or minus I like this instead of writing it separately. It makes no difference to me. Alright? Alright, well that is it for problem number 2. Alright, those were the answers to A and B. And now a word from our sponsor.
Hello. This is Maya, Mr. Burton's daughter.
You can call me Daddy. It's okay. That's all you wanted to say? Say something else.
You love Daddy.
Daddy loves you. Daddy loves you. Alright, tell them to do their homework.
Do your homework and don't copy Daddy.
Yeah. Pencils down. Alright, I'll see you on the next video, people. This video is already 20 minutes long.